to solve this, you have two sets of exponents. For this one, you will not, as you can tell, use a log. In order to solve when you have two sets of exponents like this, you need to make it so that both have the same base. If you cannot make it so both have the same base, we do not have really a method in this class to do that. So what you do is you go, okay, how can I get these both to be the same? Well, you look at the one that's smaller and you think, how can I change this one to look like a 3 or become a 3? And you notice, oh, that's 3 to the 4th. Then, once you have a power to another power, that is distributed because you multiply powers to powers. So when you distribute that, you get 8 minus 16x. This one stays the same. Since they have the same base, you could logically assume that the powers have to be equal if the bases are equal. Okay, if the bases are the same and there's an equal between, the powers would have to be the same for these two quantities to be the same. So we can make an assumption that these two have to be equal and just ignore the 3's because the exponents would have to be the same, equal. And then we just solve it using basic solving skills, and you get 16 over 19. That looks like it reduces, but it doesn't. 19 is actually prime. Okay, so that is the step. There is no log involved. This one, we get to a log, and here's why. First step is you minus the 6 over. You get 30. Then you divide by 3. Now once you're in an exponent, and your x is the variable, but you only have one exponent, not one on each side, you're going to want to change this into a log. So what you do is you write the word log in front, switch the x and the 10, and then from here that is an answer, but I want you to separate it because from here you can use your calculator to solve this, which is log 10 over log 5, and a lot of times this is how I make your answer. So if you can't go over this last step on a multiple choice test, you might miss it. So know how to take this next step. So make sure you know this is called change of base from here to here. And make sure whenever you have an exponent you're trying to solve for x as a variable in the power, you have to change it to a log. Or on number 3 here, it is a log, so you're going to change it to an exponent later on. So for this one, you got to get the log by itself, so you minus the 1 over, divide by 4. Now, with there's no base, you have to realize no base is base 10. Always remember that. That's where the 10 came from. And then I have to change this log into an exponent. Again, the log is isolated, so I change it to an exponent. I cover the log, or erase the log, switch these two values, and I get here in the green. Erase that, switch these two, and I have what's in the green. Now I just solved this. 10 squared is 100. Alright. I minus the 3 over, divide by negative 5, and there's my answer. Now, the one thing is you have to watch out for extraneous solutions if it's a log problem. So I took my answer, I plugged it into the log, and when I do that, what I'll notice is this becomes a positive value. It looks like 100, so we're okay. As long as when you plug the answer back into the log, it is a positive result inside, we're okay. Most of the time, your answers are going to be fine. It's once in a great while it doesn't work. So you want to check for it, but most of the time it's going to work.